Welcome back to my channel. Myself Kusuma, studying in Sri Venkateshwara College of Engineering. Today we'll be discussing about introduction to microwave engineering and the devices used for it. What basically is microwave engineering? Microwave engineering pertains to the study and the design of the microwave circuits, components and the systems. So fundamental principles are applied to analysis, design and measurement techniques in this field. The short wavelengths involved distinguish this discipline from electronic engineering. This is because there are different interactions with the circuits, transmissions and the propagation characteristics at the microwave frequencies. Introduction to microwave. What basically is microwave? A microwave is a form of the electromagnetic radiation with wavelengths shorter than other radio waves but longer than the infrared waves. Its wavelength ranges from about 1 meter to 1 millimeter, corresponding to the frequencies between 300 MHz and the 300 GHz broadly construed. So this is the electromagnetic spectrum. Microwave is in between the radio and the infrared waves. Microwave frequency and the wavelength. Microwaves are defined as electromagnetic radiation with a frequency ranging between 300 MHz to 300 GHz. In contrast, the wavelength ranges from 1 mm to around 30 cm. Microwave radiation is commonly referred to as microwaves. They fall between infrared radiation and the radio waves in the electromagnetic spectrum. So this is the few characteristics of the microwaves. Like metal surfaces reflect microwaves. Microwaves with a certain wavelength pass through the Earth's atmosphere and can be useful in transmitting the information to and from the satellites in the orbit. Hence the satellite dishes are made up of metal as they reflect the microwaves well. So microwaves of certain frequencies are absorbed by the water. This property of the microwaves is useful and in cooking. Water in the food absorbs the microwaves which causes the water to heat up. Therefore, the cooking of the food. Let us move on to the microwave components. First one is the waveguide. What basically is waveguide? A hollow metallic tube of the uniform cross section for transmitting the electromagnetic waves by successive reflections from the inner walls of the tube is called the waveguide. This is the two-port rectangular waveguide. A waveguide is generally preferred in microwave communications. Waveguide is a special form of the transmission line which is a hollow metal tube. Unlike a transmission line, a waveguide has no center conductor. The main characteristics of the waveguide are as follows. The tube wall provides the distributed inductance. The empty space between the tube walls provide distributed capacitance. These are bulky and expensive. Let us move on to the couplers. The directional couplers are circuits that are essential in many optical communications systems and microwave bands. A directional couples is a device capable of extracting a part of the signal that travels over a transmission line or the waveguide, leaving the rest of the power not coupled direct route at the exit. A coupler can be used to relate relative coordinates of the revolute, translational and cylindrical joints. To relate relative coordinates of the revolute, translational and the cylindrical joints, the relative coordinates may have the linear relationship which is defined as scales. Couplers are useful if the user's model uses the bells and pulleys or the chains and sprockets to transfer the motion and the energy. So this is a multi-hole directional couplers. Circulators. In electrical engineering, a circulator is a passive, non-reciprocal 3 or 4-port device that only allows a microwave or the radio frequency signal to exit through the port directly after the one it enters. Basically, where does the circulators used means the circulators are used in the radar systems. The circulator is primarily used in the signal processing in the radar systems. It ensures that the transmitted signal is directed toward the antenna to ensure minimal loss and does the same when any reflected signal is received. So as you seen in this picture, this is a microwave circulators. Let us move on to the antennas. A microwave antenna is a key device in the wireless communication, transmitting signals between two or more locations. It plays a pivotal role in the various applications including broadcasting, radar and the radio astronomy, making it indisplaceable in the tech world. Antenna plays a crucial role in this communication system, which is used to transmit and receive the data. The classification of the antenna is based on the specifications like frequency, polarization, radiation, etc. Microwave antennas are used to transmit and receive the microwave signals. These antennas are designed to operate in the microwave frequency range, typically between 6 GHz to 90 GHz. Let us move on to the microwave transmission lines. A transmission line is a connector which transmits energy from one point to another. The study of the transmission line theory is helpful in effective usage of the power and the equipment. Strip lines and microstrip lines. Let us move on to the strip lines. These are the planar transmission lines used at the frequency from 100 MHz to 100 GHz. A strip line consists of a central thin conducting strip of the width W, which is greater than its thickness, that is T. It is placed inside the low dielectric, that is epsilon r substrate of the thickness B by 2 between the two white ground plates. The width of the ground plates is 5 times greater than the spacing between the plates. Let us move on to the microstrip lines. The strip line has a disadvantage that it is not accessible for adjustment and the tuning. This is avoided in microstrip lines, which allows mounting of active or the passive devices and also allowing making minor adjustment after the circuit has been fabricated. Let us move on to the microwave devices. Let us move on to the microwave passive devices. Attenuators, isolators and the circulators and the waveguides. Let us move on to the attenuators. Attenuators are used to reduce the power level of the microwave signals. They help in adjusting the signal amplitudes to ensure optimal performance of the system. Attenuators are available in fixed or the variable configurations and are used in various applications where the signal levels need to be controlled. Isolators and the circulators. Isolators and the circulators are non-reciprocal devices that are commonly used in microwave systems to control the signal flow and prevent signal reflections. Isolators allow the signal's flow in one direction only, so helping to protect the sensitive components from the reflected power. Whereas circulators on the other hand can route the signals sequentially among the multiple ports, making them useful for signal routing and transmission in the complex systems. Waveguides. Waveguides are hollow metal tubes or the structures that are used to guide and propagate the electromagnetic waves at the microwave frequencies. These devices are commonly used in high power microwave transmissions applications, radio systems and the communication systems. Waveguides offer a low signal loss and are capable of handling high power levels, making them suitable for demanding the applications. Let us move on to the microwave active devices. So microwave amplifiers, microwave oscillators and transistors. Let us move on to the amplifiers. Amplifiers are used to increase the power level of the microwave signals. They are essential for boosting the signal strength, compensating for signal loss in the transmission lines, and improving the signal to the noise ratio in the communication system. So common types of the microwave amplifiers include low noise amplifiers, power amplifiers and distributed amplifiers. Microwave oscillators. Oscillators are used to generate the continuous wave signals at the microwave frequencies. And these devices are crucial for providing the stable and precise timing references in the communication systems, radar systems and test equipment. Microwave oscillators come in various configurations such as voltage control oscillators, crystal oscillator, dielectric resonator and the oscillators, that is DROs. Microwave transistors. Transistors are active semiconductor devices that are used as building blocks in the microwave circuits for amplification, switching and signal processing. Common types of the microwave transistors include bipolar junction transistors, that is BJTs, field effect transistor, FETs and high electron mobility transistor, HEMTs. Transistors are key components in the microwave amplifiers, oscillators and the mixes. Let us move to the application of the microwave engineering. Microwave engineering is a specialized field of electrical engineering that deals with the study of the and application of the electromagnetic waves with a frequency ranging from 1 GHz to 100 GHz. These waves are used in wide range of the application from communication system to the medical equipment and are critical to many modern technologies. One area where microwave engineering has had a significant impact is in the development of various applications and technologies. One of the most significant applications of the microwave engineering is in the field of wireless communications. The use of the microwaves in wireless communication system allows for high-speed data transport, reliable communication over the long distances. Microwave transmitters and the receivers are used in the various applications including cellular phones, satellite communication, and radio and television broadcasting. Microwave engineering is also critical to the medical industry. Microwaves are used in the various medical applications including medical imaging, cancer treatment, and microwave imaging techniques such as microwave tomography, and have shown great promise in detecting the breast cancer and other medical conditions. If you like this video, please do like, share and subscribe to my channel. Thank you.